As a part of NASA's CLPS initiative, Blue Ghost Mission 1 will deliver 10 NASA payloads to Mare Crisium, which is in the northeast quadrant of the moon's near side. This mission in particular marks a significant step forward in advancing our lunar research and enabling a sustainable presence on the moon.
Ignition. And liftoff. Fairing separation confirmed.
So we're all one team, but it's another thing to hear, especially in this moment. Like you said, really their job is beginning now.
You're looking at Firefly Aerospace's Mission Operations Center here in Austin, Cedar Park, Texas, just north of Austin, where the team has been operating Blue Ghost Mission 1 for the last 45 days since launching from Kennedy Space Center. Welcome to the live landing coverage of Firefly's first road trip to the moon with our Blue Ghost lunar lander delivering NASA payloads. I'm Bridget Oakes, the Vice President of Engineering at Firefly.
And I'm Nilfer Ramji with NASA Communications.
And for the past 6 years, I've worked with our engineering teams on everything from avionics and software to composite structures and propulsion systems for our rockets and spacecraft, including Blue Ghost. And today, I'm honored to be supporting the Blue Ghost team as your Firefly host.
Thanks, Bridget. And Firefly's Blue Ghost Mission 1, called Ghost Riders in the Sky, was awarded through NASA's Commercial Lunar Payload Services, or CLPS initiative. With NASA's Artemis campaign, we are returning to the moon to conduct groundbreaking science and leverage technological advancements before people go back. Today's moon delivery with Firefly Aerospace will help us continue on that path. And later on, Blue Ghost Mission 1 is set to touch down on the lunar surface carrying 10 NASA science and technology instruments. Just over an hour from now, we will attempt to land in Mare Crisium, a basin in the northeast quadrant of the moon's near side, or the side we see here on Earth. A little south of Mare Crisium, you will find Mare Tranquillitatis, or Sea of Tranquility. That location might sound familiar since that's where the first Apollo astronauts landed on Apollo 11 in July 1969. That's over 55 years ago.
This Blue Ghost mission has been a journey not only for our Firefly team, but the friends and family who have supported us. More than 750 Firefly employees have played a role in bringing this historic mission to life, and their loved ones have been an integral part of this journey. This impressive team is joining us now with our NASA customers watching from a viewing location just down the road from our Mission Operations Center.
I want to be there. We're joining forces for this historic moment marking Firefly's first lunar landing. It's all hands on deck since years of preparation have gone into this exact moment.
And before we touch down, let's go ahead and review our current mission status. Blue Ghost just entered a planned comms blackout on the far side of the moon where we have limited access to our ground stations on Earth. As you can see in our telemetry-driven simulation, the lander is currently in low lunar orbit, about 100 kilometers above the surface as we get ready for our descent orbit insertion, which is going to be in about 10 minutes. This critical 19-second burn will put Blue Ghost on its descent trajectory, and then we'll coast for about 50 minutes. Comms should be back online about halfway through that coast phase. We're going to walk through these steps in more detail later in the broadcast, but in the meantime, you can track the mission progress in the timeline bar at the bottom of the screen. And throughout the show, you'll see even more graphics that are driven by our real telemetry data from Blue Ghost. This includes our countdown clock in the top left corner of our gauges are going to be just under that clock, which show our velocity and distance above the moon's surface. Those gauges are frozen now, but will activate once we reacquire signal with the lander. The simulation you see is about 15 seconds delayed, so we'll be landing on the moon just before you see it on your screen. We also have a graph that will show Blue Ghost's descent phase in real time. And we have a view of the lander's foot pads and thrusters. As we get closer to descent, this graphic will show us which thrusters are firing and which foot pads have actually touched down on the surface after landing.
So for now, let's take a look back at the 6-week-long journey that led us to this point and got us closer to the moment we've all been waiting for, Firefly's first lunar landing. Blue Ghost launched on a SpaceX Falcon 9 rocket in the early morning hours on January 15th from Launch Complex 39A at NASA's Kennedy Space Center in Florida. About 6 minutes after the launch, Blue Ghost separated from Falcon to begin orbiting Earth before it went into lunar orbit. The lunar lander acquired signal about 9 minutes later, which was followed by completion of on-orbit commissioning. That moment officially kicked off that 45-day journey that's brought us here to today. Now, what you may not know is that Launch Complex 39A is where the historic Apollo missions headed to the moon. That must have felt symbolic.
Absolutely. And it was a proud moment, and a huge shout out to SpaceX for being such an incredible launch partner. Blue Ghost was deployed into a highly elliptical Earth orbit about an hour after liftoff. We then completed a 45-day transit from Earth to the moon. And this mission has been incredibly successful to date, and we're so proud of what our Fireflies and NASA have collectively accomplished. So far, we've already downlinked 27.2 gigabytes of data, including some incredible payload science from NASA. We conducted 7 engine burns during that transit for a total of 523 seconds and traveled roughly 2.8 million miles.
Wow.
This included 25 days in Earth orbit where Blue Ghost took a phased orbital approach with 3.5 elliptical orbits around Earth that got us closer to the moon each time. Then we performed what's called a trans-lunar injection to escape Earth's gravitational pull and completed a 4-day transit to the moon. A lunar orbit insertion burn was then performed to enter the moon's orbit where Blue Ghost spent the last 16 days. Additional maneuvers were performed during this time to enter a low lunar orbit. This brought us to about 100 kilometers above the moon. That's where the lander is right now as we get ready for our descent orbit insertion.
No pressure, 100 kilometers. And during Blue Ghost's road trip to the moon, Firefly was able to downlink some pretty incredible imagery. Let's take a look back at that footage. So without a doubt, no matter how many times I see these, I am proud, inspired, and frankly speaking, just blown away at how stunning our Earth and moon look in the darkness of space. Now, when you're headed to the moon, that trip can vary depending on the selected route. Some might be a lot quicker than others, but Firefly chose that scenic route.
We did, and there are a lot of benefits to that scenic route, actually. With that 45-day transit, we were able to conduct rigorous health checks on each Blue Ghost subsystem and on each of those NASA payloads. This route also gave us ample time to calibrate our propulsion system ahead of each of those critical maneuvers. We could then analyze the data from each burn so we could better predict performance and optimize our trajectory. Once we entered lunar orbit, we also had more time to calibrate our vision navigation system and verify its operations, which enable that precision landing. And most importantly, we were able to conduct payload science operations throughout that road trip and capture some incredible data for our NASA customers.
Our NASA payload teams are pleased with the science and tech operations they have been able to conduct while Blue Ghost has been in transit. Among the 10 NASA instruments being delivered, I'm happy to share that all of them are expected to be healthy, so they are ready to work shortly after we touch down on the moon this morning. We'll be talking through the largest CLPS manifest to date in more detail later on, but off the top, we do have a couple of key highlights we can share. The Lunar Global Navigation Satellite System Receiver Experiment, or LUGRA, tracks signals from the Global Navigation Satellite System at a record-breaking distance of over 200,000 miles while Blue Ghost was in transit. This data can help enable GPS-like solutions on the moon, which is really exciting. LUGRA is a collaboration between NASA and the Italian Space Agency. Another instrument, the Radiation Tolerant Computer, or RAD-PC, also began demonstrating the computer's ability to withstand space radiation while passing through the Van Allen radiation belts. I'm personally looking forward to the surface operations to collect more of that important data and science. But before we get into that phase of the mission, we're getting really close to that next milestone.
Blue Ghost is set to perform its descent orbit insertion burn in just a matter of minutes, which will place the lander on its descent trajectory. As mentioned, this 19-second engine burn is performed on the far side of the moon during a planned comms blackout. So we're going to check back in with the team to confirm if it was successful once we reacquire that signal. If anything is off nominal, we'll actually get another shot at the descent orbit insertion. If everything looks good though, then Blue Ghost will continue through its coast phase. We'll then perform a powered descent initiation and begin our D'Souza guidance phase around T-minus 12 minutes to landing. We'll talk more about each of those phases as we get closer, but in total, our entire descent takes about an hour.
And this entire descent phase is autonomous, right? So meaning she's built and programmed to do exactly this.
Exactly. However, Firefly does have the ability to override the descent and send commands to the lander as needed up until that powered descent initiation or the braking burn.
Got it.
That lasts about 9 minutes. It's at that point that we let Blue Ghost take the wheel before touching down in Mare Crisium. If you're looking at the moon from the Earth's northern hemisphere, it's a large basin that's located in the northeast quadrant of the moon's near side. This landing site was actually chosen by NASA. Can you tell us a little bit more about how that decision was made?
Yeah, of course. The landing site selection for CLPS has been an interesting evolution since the initiative has matured and the different contracts have been awarded. In the early days of CLPS, companies chose their landing sites that suited their lander performance and safety. But with later CLPS contracts like this lunar delivery, NASA selected the landing site based on the data requirements for the agency's science and exploration goals. Mare Crisium was selected for this mission because it has a large impact basin. There's a lot of good data that can be collected here about the basin's chronology and the different volcanic features. It may also help us understand the volcanic history on the moon, including how it formed and evolved. This particular area was chosen in part to avoid magnetic anomalies on the lunar surface that could interfere with some of the observations we needed to take of the Earth's magnetosphere. The science teams also looked for things like rock abundance because there's a drill, but rocks can also be dangerous, especially during a landing. So finding that right balance was key. More than anything, NASA wanted to make sure that the science goals could be accomplished while also ensuring it worked for Firefly. Now, within Mare Crisium, Firefly will be landing in a particular volcanic feature called Mons Latré, which was named after a French scientist who is considered the father of modern entomology. In fact, he named dozens of insects in the Lampyridae family, commonly known as fireflies or lightning bugs.
And naturally, the Firefly team named the volcanic feature Mount Firefly.
So I was told that.
Are there any other goals that NASA is actually looking to conduct while we're there?
Yes, there is one goal I wanted to highlight. It's personally my favorite goal. So another one of the science goals NASA is looking to do is looking at the limb or horizon, so before, during, and after a lunar sunset. And that said, the location of Mare Crisium also allows us to capture visuals of the lunar sunset after Fireflies operating on the moon for a complete lunar day, which is about 14 Earth days. There was one person who saw this in real life, and that was Apollo legend and former NASA astronaut Eugene Cernan. He captured this unique phenomenon during Apollo 17, where he observed somewhat of a horizon glow. Something about this glow actually caused the lunar dust to levitate from the lunar surface. So in order to share this with the science community, Cernan sketched this phenomenon that we can see right here on our screens. Now, NASA is interested in seeing this again over 50 years later through the eyes on Blue Ghost. Firefly is ready to capture this phenomenon during lunar dust conditions and further prove what the last astronaut to walk on the moon saw taking place.
That's a moment I'm truly excited to witness and share, and maybe make a little postcard and send something out. Let's go ahead and take a closer look at Firefly's Blue Ghost lunar lander.
Firefly's Blue Ghost lunar lander was designed for stability. It's about 6.5 feet tall and 11.5 feet wide, so it has a low center of gravity and a wide footprint. Blue Ghost has a robust communication system with one X-band antenna and 3 S-band antennas that enable HD video transmission from the lander to Firefly's Mission Operations Center in Texas. The lander has 3 solar panels to help power Blue Ghost and our 10 NASA payloads during transit and on the lunar surface. For propulsion, Blue Ghost has 8 RCS thrusters, or reaction control thrusters, that Firefly designed and built in-house. These thrusters help maintain the lander's orientation during maneuvers and independently perform the final descent by pulsing for a soft landing. We have 12 attitude control system thrusters that help point the spacecraft in the right direction. These are actually the same ACS thrusters we use on our Alpha rocket and Electra orbiting vehicles. Blue Ghost has one main engine that provides high thrust for our lunar orbit insertion and braking burn prior to landing. The lander has 4 propellant tanks that carry our hypergolic fuel and oxidizer. We have 2 pressurant tanks that carry our helium. Blue Ghost is equipped with 49 struts that connect our upper and lower panels to provide a rigid structure. These struts were built in-house using the same lightweight carbon composites we use on Firefly's launch vehicles. Blue Ghost has 4 carbon composite legs and foot pads that utilize crushed core honeycomb to absorb shock and stabilize the lander as it touches down on the lunar surface. Our foot pads have contact sensors on the bottom that signal engine shutdown upon landing. We have vision navigation software that supports landing by identifying potential hazards on the moon, such as rocks and craters, before determining the safest landing site.
Now joining us from Firefly Mission Operations Center is Ray Ellensworth, Firefly's spacecraft program director, who you may have recognized from our Blue Ghost launch broadcast.
Yeah.
Thanks for stepping off console to chat with us before landing. How are you feeling? How is the team feeling?
Yeah, I'm feeling good. I think the excitement is rising. I'll say the Mission Ops Center right now is actually like really calm. So that's nice. The team's practiced this many times, so like I think they're just ready for it to happen now.
The viewers actually just got a quick look at Blue Ghost, but I'm sure there are a lot of questions about how the lander's performing now that she's in space and almost at her destination. What has surprised the team the most about how the lander's been performing during this transit?
Yeah, that's a great question. I think the lander is really, it's really behaved really well. We haven't had any major anomalies, which is fantastic. I think the team's kind of had to get used to, different alarms, kind of calibrating those. We started off really conservative, so we kind of had to gear in on that. Also, coordinating with 10 different payloads can be kind of complicated, but so far it's gone really well. So that's
awesome.
That's a plus. Yeah.
And Ray, I really wanted to hear about the design and manufacturing process. Can you tell us a little bit more about that?
Yeah, absolutely. So a lot of our Blue Ghost is built in-house, which is amazing. I'd say really focusing on our vertical integration. There's a lot of carbon composites on there. I think all of our primary structures are carbon composites made up at our rocket ranch. So are our core avionics, our harnessing, our battery, and like all of our fluid lines. So going into this, we really wanted to build a really robust system, but also a really like structurally sound one. You look at our lander and it's a little bit shorter, it's a little bit wider. So we're really, designing it for stability on the moon.
Awesome. So of course, we talked about the RCS thrusters a little bit, right?
Yeah.
And so we like to lovingly call those Spectre.
Yes.
They are a 200 Newton hypergol engine, which we started development for in mid-2022. And by that December, we were already doing the testing.
Yeah.
And then in 2 years, we did all of the development, the qualification, the acceptance testing, and then we built all of the 8 flight engines. Right.
Yeah.
So Bridget, you worked on these RCS thrusters, if I remember correctly. Do you want to tell us a little bit about that evolution or that process?
It's a lean team, right? So we started 2022 with maybe 4 people, not even
Maybe.
30 years old.
Yeah.
Yeah, exactly. And it was just such a fast turnaround with all of that development, that energy. We learned a lot from NASA and previous Apollo missions. We took that heritage, and through all of that iteration and testing, we've had some pretty successful firings so far in space.
Yeah.
That's definitely a fast and furious trip to the moon that's led us to today, but inspiring just to say the least. So Ray, thank you so much for being here. Bridget, thanks for your insights. We want you to get back to mission control, but we'll catch you hopefully after the landing.
Yeah, I'll see y'all after. Thank you.
See you later.
Bye.
In 2018, NASA started a new, very different and innovative approach for doing science on the moon. As NASA explores the lunar surface under the Artemis campaign, we want to leverage the capabilities of American companies. So rather than NASA owning the missions and operating traditionally, we made a concerted effort to use commercial services and public-private partnerships. And Commercial Lunar Payload Services, or CLPS, was born. Let's take a closer look at NASA's CLPS initiative, which is helping bringing Firefly's first mission to life.
Our moon. It seems so close in the late sky, but getting there is really hard. But what if there was a way?
I don't ever slow up, no I don't take shit. I got no love for the fakeness. If you wanna play tough and wanna hate this, I'll always show up and make a statement. I don't ever slow up, no I don't take shit. I got no love for the fakeness. If you wanna play tough and wanna hate this, I'll always show up everything I do so instinctive and so passionate. Every word I move so descriptive like an adjective. I got a vendetta against people who patented being negative when you should be getting after it.
We are enabling
I got
American
facts over
companies
facts
to
over
send
tracks,
our
this and that,
payloads to the
spitting
lunar
slow,
surface.
spitting fast, I could roast,
These
I could
delivery
gas, think I'm
services
okay at
will
last, but I
expand
don't know if that can erase all the past
Radically
and the
increase
pettiness,
the amount
a
of
reflection
science
of the emptiness, hilarious, you think you're worth my time, you're delirious, mysterious, because you hide behind a fake exterior, inferior, you know I'll always be a bit superior, get off of me, this ain't no humble brag, I want you to hear words, you can say them back, I want you to feel free from the chains at last, and to believe in what you got, it was built to last, yeah.
Access to the moon.
Now that I've been put
We
through
will be able to
hell,
make novel
I
measurements
never got
and develop
anyone's help.
technologies that
I had to
scientists
do it all
can
myself.
do on the lunar surface.
I don't ever slow up, no I don't take shit, I got no love for the fakeness. If you wanna play tough and wanna hate this, I'll always show up and make a statement. I don't ever slow up, no I don't take shit, I got no love for the fakeness. If you wanna play tough and wanna hate this, I'll always show up and make a statement. Gonna learn the
If you're just joining us, we are now past that hour mark with just T-minus 52 minutes until landing. This moon landing is for Firefly's first mission to the moon. The company's Blue Ghost lunar lander is still in a planned communications blackout, and we expect to gain signal in approximately 10 minutes after Blue Ghost emerges from the far side of the moon. While we get ready for that next set of milestones before landing, let's take a moment to talk through this flight manifest. This is the largest payload manifest on Eclipse delivery with 10 NASA science and technology instruments on board. Diving right into the NASA payloads on this flight, we have the Next Generation Lunar Retroreflector, or NGLR, which is a passive instrument, meaning it does not power on. Instead, it will beam incoming laser light from Earth back in the same direction. The time it takes for the light to bounce back can be used to calculate the moon's shape and distance from Earth. Another payload on this flight, the Lunar Environment Heliospheric X-ray Imager, or LEXI, will aim to capture the first global images of the magnetic field that shields Earth from solar radiation, providing insight on how space weather impacts us here on Earth. During transit, LEXI operated for more than 50 hours total in preparation for collecting images from the lunar surface. Now let's talk about RAD-PC next. RAD-PC is the radiation-tolerant computer demonstration. You can't send just any computer into space. That harsh environment in space and on the moon can lead to malfunctions, system crashes, and permanent damage. Designed to recover from issues created by radiation, RAD-PC provides a cost-effective solution for a radiation-tolerant computer, which, if effective, could improve the safety for future Artemis missions. Now, during transit, RAD-PC successfully operated while passing through the Earth's Van Allen radiation belts, a positive sign that the computer is working as intended. Next up, we're going to talk about the Lunar GNSS Receiver Experiment Payload, or LUGRA. We discussed earlier is jointly developed by NASA and the Italian Space Agency. LUGRA is investigating whether Earth-based global navigation satellite systems, or GNSS signals like GPS, can be used for space-based positioning, navigation, and timing from a spacecraft's initial launch to lunar landing. During transit to the moon, LUGRA successfully tracked GNSS signals from GPS and the European Union's Galileo constellations and broke the record multiple times for the farthest GNSS signal acquisition ever, peaking in lunar orbit at 243,000 miles from Earth. LUGRA's signal reception on the moon's surface could mean a lot of things for future Artemis missions and the space sector. These are just 4 of the 10 payloads being delivered to the moon today for NASA. So let's head over to Antonia Jaramillo to learn more about SCLPS and EDS, some of our dust instruments on this flight.
Hey,
Thank you, Nilifer. We are here at our viewing location for Firefly's moon landing, and joining me is Kristen John, the technical lead for NASA's Lunar Surface Innovative Initiative. Kristen, thank you so much for being with us here tonight.
Thank you for having me. Glad to be here.
Now, Kristen, you're kind of the expert on all things lunar regolith or lunar dust. Can you tell us why it's so important that we study this?
Yeah, absolutely. So if we think about where we're going tonight to Mare Crisium, and every location that we go when we go back to the moon, we're learning something new about the sites that we're going. We're going to learn a lot of geology from studying the lunar dust and the lunar regolith. But from an engineering perspective, it's actually really interesting and really important that we study the dust or the regolith. So we learned from Apollo what a huge challenge and what a huge barrier the lunar dust can be for all of the equipment that touches the lunar surface. So if you think about the household dust that we have, that's not what the lunar dust is like at all, right? So we have a different environment on the moon. So on Earth, we have an atmosphere that protects us, but on the moon, we don't have an atmosphere. So over the billions of years that the moon has been around, it's been bombarded by these impacts and by meteoroids. And so that's created this, these impacts that have created this fine dust. So we have this really small particulate. And then on top of that, because we don't have erosion on the moon like we do here on Earth, the particulate is also very sharp. So it's much more like fine pieces of glass or shards of glass. And then on top of that, we also have this electrostatic nature of the dust because it's very dry and because of the different properties of the environment. So now you have this small, sharp, sticky dust. So when you send any equipment there, it affects literally everything. So as we go back with Firefly tonight, or this morning, I guess, and any mission that goes back to the moon, we're going to learn so much more about the hazards of the dust and how we can improve with every mission that goes back.
And on this mission, one of NASA's science instruments is the electrodynamic dust shield that's going to actually help us, mitigate that lunar regolith. Can you talk to us a little bit more about that instrument and how it's going to also help our future astronauts when we go back to the moon?
Yeah, absolutely. So EDS is a fantastic technology. So it's an active technology that actually has these transparent electrodes on different surfaces. So you can put it on a radiator or a solar panel or glasses or camera lenses to protect them. And it basically creates an electric field. And when you see it work, it looks like magic. But it basically creates an electric field that gets the lunar dust particles to basically walk off of the surface, whatever the surface is. So you can imagine in the future, any surface that might have dust that accumulates on it, which will be a lot of surfaces, whether that's a visor on a spacesuit helmet or camera lenses, even spacesuit material, you could use something like EDS to literally walk the dust off of the surface.
That is so cool. Kristen, thank you so much for joining us. Now we'll send it back to our hostess, to Nilifer and Bridget.
And thank you, Antonia and Kristen. Checking back in on Blue Ghost status, the team here in Firefly's Mission Operations Center continue to track the lunar lander as it begins its next set of maneuvers.
Alcon.
Teams.
Blue Ghost lander has achieved nominal descent orbit insertion delta V for lunar landing.
That is fantastic news that we just heard right there.
All consoles were proceeding.
Alcon journal log attached.
Copy. All consoles were proceeding to step 45.6, post DOI and blackout lander status check. Starting with payload.
Nominal.
COM.
Nominal.
Ground software.
Nominal.
Flight software.
Nominal.
AVI.
Nominal.
VNS.
VNS is nominal.
GNC.
Nominal.
FIDO.
Wait 3.
Copy. Prop.
Standby.
Copy. TCS.
Nominal.
Systems.
Holding.
Copy. FC.
Nominal.
Copy. Holding for FIDO and prop.
All right, we heard some of those call outs right there. So teams actually are a little bit ahead in terms of gearing up to attempt. They performed the descent orbit insertion. The DOI took place on the far side of the moon. During
Flight
DOI.
is nominal.
Copy.
All right, we're hearing calls out. Everything continues to be nominal, but during DOI, teams were actually in that planned communication.
Flight prop is nominal.
Copy. Systems.
Systems nominal.
C.
C is nominal.
Copy. All consoles nominal, post DOI and blackout.
Fantastic news. So we came out of that communications blackout and we completed
GNC
that.
verify 45.7.
So we completed that DOI, that descent orbit insertion, and we are coming out from
Alcon
that.
Ops, please be advised that there is 7.5 minutes until we start our slew from Suntrack to VNC Vector. This slew will orient the vehicle from pointing at the sun to pointing along the anti-velocity vector, and this will be one of 3 remaining slews of the mission. The second slew will occur when we switch our ephemeris to use the navigation filter solution. This is expected to take about 10 seconds, which means that we may or may not observe this in our live telemetry data rates. The third and final slew will occur about 6 minutes before ignition, and this will take us from pointing along the anti-velocity vector to pointing along the final descent vector in preparation for the braking burn.
All right, so those are just some of the nominal call outs we were expecting a little bit ahead of schedule. And Bridget, we did tune into the Mission Operations Center to hear some of those nominal call outs, but can you give us a little sense of what we can expect next?
Alcon and Ops, this is VNS background. After reviewing the logs, I've seen successful configuration in video mode on all 10 Argus cameras.
That is wonderful news.
And you can also see those gauges have started to update now that we have that acquisition of signal.
Alcon FC on Ops. Want to note that in about 9 minutes, we are going to have an LGA swap during that slew that was just mentioned. We'll see a slight blackout for up to 40 seconds.
Now that's wonderful news. You heard it here first. Firefly just completed that successful descent orbit insertion burn. Blue Ghost will now continue to coast with all engines off for approximately another 20 minutes before that next milestone, that final no-go poll to begin landing operations. All right, so we do have something really fun while we wait for that next set of milestones. Bridget, you brought me a little gift here. It kind of reminds me of, it's reminding me a little bit of something I would maybe make a salad in, or maybe make some stir fry in. What do we have here?
Exactly. So this is one of our foot pads that we actually tested. And it's funny that you mentioned that it looks like something you might stir fry in, because we actually, for the first demo of this, we took an industrial walk and tested it. That went well. So then we actually leveraged our composite technology, and we made an actual prototype of what our foot pad is that we've flown here.
So what are we looking at here with this foot pad?
So, and it's actually pretty cool too, because in Apollo, we took a ratio of the lander mass they had to the diameter of that foot pad. So we took that same type of design, scaled it for our lander. And so that's what you have at the base here. And then you have a ball and socket joint here for the lander to allow it some mobility when it lands. So it's in a stowed position that's not quite perpendicular to the ground. And then once it lands and it starts contact with the surface, it'll snap perpendicular. And I'll spin this around here. And we actually have one of the connectors here. So when you see those foot pad sensors turn blue on your screen, what's actually happening is there's a brake wire that runs up this leg to this connector, and this will actually snap. And that disconnected joint is what triggers those foot pad sensors to turn blue. So pretty cool design.
And that's that graphic we'll see a little bit later on.
Exactly.
And so from what I understand, this is actually, that you said it's a real test article that was used before she went into space.
Exactly.
It's in really great shape.
It is. So successful design. I mean, you can see some scratches on the bottom, but we don't have any major dings or anything like that. Yeah, definitely very successful.
And you said that there is a way for some level of shock absorption?
Yes. So, I mean, we are planning to touch down at about 1 meter per second, but we are still designed for something as much as 5 Gs and only 2 legs landing. You know, we want to try to put in enough margin into this as possible so we're successful. And what we, I don't actually have a piece of the honeycomb core here, but you'd actually have a cylindrical section inside this lander leg that acts similar to something in your car that crushes. So it would be a plastic deformation of that core inside of here. So maybe anywhere from 1 centimeter to 1 inch of that will actually compress and absorb some of that shock from that landing.
I hope you have other goodies to show me a little bit later on, because I'm fascinated by this. And as we wait to learn more about about the mission, some of our other NASA payloads on board will continue to to talk a little bit more about those. So another instrument on this flight is the Lunar Instrumentation for Subsurface Thermal Exploration with Rapidity, or what we know as LISTER. It's equipped with a drill and a thermal probe which will dig up to a depth of 3 meters into the lunar surface and take some thermal measurements. By making similar measurements at multiple locations on the lunar surface, LISTER could shed light on the geological processes that shaped the moon. Now, next up, we have the Lunar Planet Vac, which is designed, it's LPV, and it's designed to collect lunar soil samples from the surface using a burst of compressed gas to drive the soil sample into the container, and additional instrumentation will then take images of the container's contents and transmit those results back to Earth. The LPV payload is designed to help test low-cost technologies for collecting and analyzing samples, improving our ability to search for water, helium, and other potential resources on the moon. We learned during the Apollo missions that lunar dust, or regolith, is very challenging to work with. It's extremely abrasive and actually clings to everything: gloves, boots, vehicles, and mechanical equipment. Now, next up, to learn about the potential challenges that dust poses to future Artemis era missions, the Regolith Adherence Characterization Instrument, or RAC, will measure how lunar dust accumulates on different surfaces and materials. The data captured could help more effectively test, upgrade, and protect spacecraft, spacesuits, habitats, and equipment in preparation for continued exploration of the moon. NASA's Lunar Magnetotelluric Sounder, or LMS, will probe the interior of the moon to depths of up to 700 miles. Now, that's 2/3 of the way to the lunar center. The measurements will shed light on the differentiation and thermal history of our moon, a cornerstone to understanding the evolution of solid worlds. Now, while we eagerly await that next milestone, let's talk a little more about the team. As you can imagine, there are several people that have worked tirelessly to make this mission happen. And Team Firefly's Blue Ghost team are lovingly known as the Ghost Riders.
They are. And right now we have about 20 Ghost Riders on console at Firefly's Mission Operations Center just north of Austin, Texas, that you can see on the screen right here. In total, Firefly has more than 50 team leads that rotate on console throughout our 60-day mission, including transit and surface operations. These console leads represent key operations and Blue Ghost subsystems, including propulsion, thermal, GNC, avionics, payload leads, and more. They've been checking Blue Ghost health status and sending commands to the lander throughout the entire mission.
And Bridget, you come to us with this kind of experience too, right? You were on console for Blue Ghost's launch, if I remember correctly, and for many other rocket test campaigns. What's it like being in that room? How does it feel?
High adrenaline, for sure. But it's a moment that you train for continuously. Take launch, for example. As a propulsion engineer, you've already been hands-on with the hardware from day one. You've worked on the valve design, you've tested the subcomponents, you ran the engine development, the qualification, the acceptance campaigns. By the time that you're actually on console, you've already been through so many iterations of tests, which all lead up to that moment. And Blue Ghost is no different. It might be our first mission, but this team has already run 6 engine test campaigns, over 24,000 engine starts.
Wow.
Along with valve and battery tests, thermal vac, shock, vibe, and countless ops rehearsals simulating every off-nominal scenario imaginable. And this team is just, they're ready.
Everything under the kitchen sink.
Exactly. And everyone, engineering, supply chain, business development, welders, all came together to make this happen. We asked them who they dedicate the mission to, so let's listen to what they have to say.
If I could dedicate the mission to anyone, it'd be the Blue Ghost engineers at Firefly.
I'd have to dedicate it to my brother. He's very special needs, so he doesn't get to necessarily pursue a lot of these kind of things.
I'd probably dedicate it to Dr. Woody Flowers.
If I could dedicate this mission to anyone, it would be
I'd dedicate it to my son, Bear. He's a year old, and he's named after me and my dad, Barry. Our names are on the plaque that's honoring us, so our names are going to be on forever.
My 4 kids, but they're
my dad. He passed shortly before I joined Firefly.
So I would like to dedicate this mission to the future generations of space exploration.
I would dedicate Blue Ghost Mission 1 to every single person in high school or college, or even graduated and working in a different field, who thinks that they're not good enough for space. I thought the same thing until I tried for it, and I was able to do it. And there are many, many people who are far smarter than me who feel the same way. So give it a shot. Take your own moonshot. That's what I did.
I'm inspired and just a little emotional after watching this. All the Fireflies and their families have been supporting the mission, including someone who's joining us right here. We have Ariana Mary, one of Firefly's spacecraft flight software engineers. Hello, and I'm sure you've been on the edge of your seat like the rest of us who are looking forward to today's moon landing. How are you feeling?
I'm feeling incredible, thank you. It's an incredibly exciting time, not only because, all the technology and goal behind the mission is so exciting, but also because of what it means to so many people. We're landing on the moon. It sounds like something so outside of everyday life, but honestly, for a lot of people, this has been their everyday life for the last few years, thinking of this mission. They've met so many friends while working this mission. They've met their partners, so it's impacted a lot of lives, and it's not even on the moon yet.
And you've worked on both the Blue Ghost mission and Elytra mission. Can you tell me a little bit about the team dynamics? How does that work?
Yeah, there's a lot of cross-pollination, a little bit of everything. The culture at Firefly is honestly fun to work on because you have people that are incredibly capable in their fields, but also just fun to work with. Everyone expects a lot of you. You have to own your piece and deliver for the mission because no one can get to space on their own. But at the same time, everyone's always willing to lend a helping hand. If you share a problem you're stuck on, or honestly even mention it in front of a lot of Fireflies, they're very eager to offer their help and make sure we can all get there together.
That's really exciting. And excuse me, Ariana, I think a lot of people that are watching this are seeing that you've started your career at Firefly. How did you get to where you are? What did you study to bring you to this role?
Yeah, so I was a computer science major in college, and so not an aerospace major, actually. And a lot of people don't have aerospace degrees that work in aerospace. There's a lot of jobs that are required to help us get there. And I applied online, and I'm not joking when I say this. I applied not thinking that I'd get it. Not humbly, I just applied as an exercise. Almost didn't do it, and it ended up really well. So I think about what would have happened if I didn't apply. So like Joseph said, if anyone is thinking about it, nothing bad can happen. Just give it a shot.
Yeah, take your shot. And I think I have to ask, because we just watched this wonderful tribute video, who are you dedicating this mission to?
Yeah, despite obvious contributions to me being here, my parents, I'd have to give it to them because I wouldn't be here without their constant support and their leading by example, I would say. And it's also not mine to dedicate, but I would also give it to the other Fireflies who worked on this mission. I've watched people pour their hearts into this, so I'll definitely be thinking of them when we land.
Is there a particular memory or experience that stands out in your mind in the last few years?
The last few years, all I can think about is the recent events. There's so much craziness. I've learned that all the people behind these great technologies are just people, and they're always fun to work with. Recently, honestly, the memory coming to mind is doing push-ups in the operations room. Once we launched Blue Ghost, we've had 24-hour comms since launch, and even during the blackouts once we entered lunar orbit, where there's always people in the room, we never leave console. So that's a lot of overnight long shifts, and so you got to do stuff to stay awake, and that's been my life.
Take out that nervous energy,
exactly,
maybe too.
We're all supposed to be swole by the time we land. So.
All right, thank you so much for being here, and thank you for your contributions to the mission. We look forward to talking to you after landing. Now, through CLPS, NASA is buying a complete robotic lunar delivery service. Under this innovative model, NASA is one of many customers alongside commercial companies, universities, international partners, all with the common goal of sending payloads to the moon. Now, there are risks, and NASA is embracing a higher level of risk tolerance by leveraging commercial solutions to send rapid, low-cost deliveries to the moon, fostering a growing lunar economy. Let's take a look.
Landing on the moon is hard. We're going back. Under this Artemis program, we're going to be sending humans to the moon for the first time since Apollo. So ahead of humans, we want to get up as much science, exploration, and technology experiments as possible.
So CLPS starts facilitating a lot of the early science, the things we want to learn before we even send humans. CLPS stands for Commercial Lunar Payload Services, CLPS.
The services part is the key element. Ordinarily, when NASA delivers a payload to the surface of the moon, they do it with a commercial partner, but NASA controls the building of the vehicle. Now, we're buying the service of delivery of our lunar payloads to the surface of the moon.
It is a delivery service, akin to a delivery service that you'd have here on Earth.
NASA will provide payloads to a commercial company. They decide how to get it to the moon. They have to develop their own lander, but they also have to manage the entire end-to-end mission.
It's meant to provide affordable, rapid, frequent access to the lunar surface through American companies.
We're funding different companies.
We have commercial companies that are competing to win task orders to deliver our payloads to the surface of the moon.
One of the goals when we started CLPS was to help establish a lunar economy.
Somebody has to do it first, and then it becomes commercially available. Then they're able to crank them up. Then they're able to make it more affordable. And so the lunar surface is just the next frontier for a commercial environment.
But we had to acknowledge up front, all the way through the highest levels of the agency leadership, that some of them will fail. These missions may not be as successful as a traditional NASA mission.
We have accepted the risk that going through this innovative approach with these commercial companies, that there could be some failures. Some of them are new companies. None of them have ever successfully landed on the surface of the moon. So they're going to learn lessons.
We need to give our vendors the opportunity to learn.
And so that'll help ultimately buy down our risk as these companies learn, okay, what does it take to actually build up the lunar lander, integrate payloads, get to the lunar surface and land safely?
They've been able to demonstrate that they have very, very good technical depth and the ability to design and execute missions. We're willing to take more shots on goal. And we aren't risking human lives. And in the big picture, if we're flying missions at 1/10 of the cost of a NASA mission and we fail 2 of them, we still get 8 missions for that same price.
Even with 1 or 2 or 3 failures, this is still a very economical proposition. It's a risk posture which is more risk tolerant than NASA is accustomed to. There's not a single one of these companies that's willing to bet their mission on a coin toss. Every one of them is doing what they can in order to have the most successful mission possible. But the important thing to realize is that risk tolerant does not mean risky. And the rewards are a long-term ability to get payloads to the moon inexpensively, frequently, and rapidly.
We want science, so we can then put more of our resources on even more science, exploration, and technology payloads and get more of a return on investment when we get to the moon.
CLPS provides tremendous benefit across the scientific and economic communities.
So there's a lot we'd like to learn about the moon to help human habitation and prepare us for missions to Mars and beyond.
So the moon is the first step.
Now let's head over back to Tony to speak to one of NASA's leaders.
Hey, thank you so much, Nilofer. It's always an honor to be joined by NASA leadership, and joining me now is NASA Acting Administrator Janet Petro. Janet, how are you feeling with less than 24 minutes to go until landing?
I can't tell you how excited I am right now to get to be here and experience the landing on the moon. That's coming up is very, very exciting. So I'm very excited for this moment.
Same here. Now, Janet, can you tell us why it's important that we maintain an American presence on the moon?
Well, I think this administration really wants to keep America first. And I think the way that we keep America first is by dominating in all the domains of space. And the space domain of space we're going to capture recently tonight is going to be on the surface of the moon and around the moon. So as long as we keep dominating that space, I think we're going to be putting America first. We're going to make America proud. We're doing this for the U.S. citizens. So very exciting, and I really think we need to keep pushing forward. And as it's been described all this evening, the Commercial Lunar Payload Services, this program, which marries NASA, a little bit of seed money with the commercial private industry, bringing them forward, building that lunar economy. Building that economy is what's going to make us dominate in and around the moon, so we've got to do it.
That's very well said. Now, on this mission, what are you most looking forward to learning about from all the NASA science that's flying aboard?
So there's a lot of NASA science. You've heard that multiple times tonight. And you heard about the, the study of the lunar surface and the soil and all that. But the one payload that I'm most excited about is the electrodynamic dust shield, because it was that technology was developed at the Kennedy Space Center, and I know that team is so excited to see that technology go to work on the Blue Ghost. And I think everyone remembers from Apollo the difficulty of all the dust and how it would cover the cameras and on the vehicle itself and the solar panels. And so by having this electrodynamic dust shield, it'll prove out that technology, which the dust will not be a problem, hopefully, as we go forward.
I'm really excited of learning of that one myself. And just like you, I'm also a Kennedy gal, so huge shout out to the EDS team. Now, Janet, is there any message you'd like to say to our public here as we get ready to land on the moon?
Yeah, I would say thank you to everybody for their support. And I would also in particular like to thank the Firefly team. Earlier today I was talking to Jason, and he was talking about his team of people, and I got to see a couple of them, but I can tell you they are motivated, they're dedicated, they're relentless, they persevere, and they're really going to be successful. And then to the NASA teams that has all worked very hard to get to this moment, I want a huge thank you and shout out to NASA, the CLPS, the Science Mission Director, for all they've done to make this moment possible.
Well, Janet, thank you so much for joining us here today. Now we'll send it back to Nilüfer and Bridget.
Thank you both for those insights, and shout out to KSC. We are now in the final moments of descent. If you're just joining us, this is the NASA Firefly lunar landing broadcast for Blue Ghost Mission 1 as part of the agency's Commercial Lunar Payload Services, or CLPS initiative. With just less than 21 minutes before touching down on the lunar surface, the team is planning to conduct that final go, no-go poll for the powered descent initiation, or PDI, in about 5 minutes. Now, while we get ready for that, I know there are a few more steps before the actual touchdown. What can we expect in the upcoming descent phases?
For our next descent phase, Blue Ghost will perform a fully autonomous powered descent initiation, which is a 9-minute braking burn that utilizes all engines to reduce Blue Ghost's orbital velocity from 1,700 meters per second down to just 40 meters per second. It's during this time that Blue Ghost uses D'Souza guidance to position itself above the target landing site, where we'll pitch over from a horizontal to a vertical orientation.
And if you're not familiar with D'Souza, it's considered the optimal guidance law for planetary lining. And Christopher D'Souza is credited for this. D'Souza's model is actually very similar to the guidance model used during the Apollo moon landings.
Exactly. And during the D'Souza guidance phase, Blue Ghost is fully autonomous.
No pressure.
We won't be sending any more commands to the vehicle until we touch down on the surface. We trust the lander to do what she was designed to do. Following D'Souza, Blue Ghost will enter the terminal guidance phase at T-minus 100 seconds to touchdown. Blue Ghost's main engine will shut off, and our RCS thrusters will perform the final descent by pulsing as needed to reduce our descent rate down to just 1 meter per second. So it's like a slow walking speed. It's during this phase where our vision navigation system is actively scanning the lunar surface, assessing things like craters, slopes, and rocks to automatically select a hazard-free target that's within our landing zone. Starting at T-minus 11 seconds to touchdown, we'll then enter the landing guidance phase, and it's during this phase where Blue Ghost's descent rate is maintained at that 1 meter per second.
And I'm already feeling those nerves. That landing descent profile has to be precise. It's very, very impressive. Now, throughout this entire descent, do you keep the engines firing, or do they all shut off? What can we expect there?
Great question. So those Spectre engines we spoke about before, they're designed to pulse. They give us a very fine-tuned control during descent. Each of those engines fires 4 times in a second, anywhere from 60 milliseconds to 235 millisecond bursts. So about as quick as a bird flapping its wings, or as long as a blink of an eye. Then, once the lander's foot pads detect contact with the surface, they send a signal for the engines to cut off. And what you see on the screen now is a visualization of these contact sensors to show which of those footpads have successfully touched down on the surface.
Now, that procedure sounds so simple when you explain it, but we both know how much work it got to get to this point. We know how we are going to land, but what will we see? And most importantly, what about the pictures?
So to set the stage, there's two types of antennas that we talk about here. We have an S-band antenna, which you can kind of think of as our lower resolution SD antenna, and then you have your X-band, or our high resolution. The plan is to use our S-band antenna to send our first images, hopefully within about 30 minutes of a nominal landing. But if that data rate is too limited, we're going to switch to X-band. This takes a little bit longer to deploy and calibrate, but once it's up, we're going to have a much faster downlink for high definition images and video.
So that was really helpful, and hopefully we can expect those images to come in shortly after we touch down on the lunar surface. So at this point in time, we got a little preview of that landing sequence, and thank you so much for sharing what we can expect. I'm really excited to see those first images.
Step 47.2.
So we heard that call for that go, no-go poll. Teams have been training for this mission and are now getting ready for that go, no-go poll ahead of that PDI we talked about, or that powered descent initiation. Here's what to expect now. If the poll's a no-go, Firefly does have another opportunity to do another orbit around the
Falcon
moon.
and Ops. SLU has begun to our final descent vector. 1 minute until SLU completion. GNC verifies step 46.2.
So as I was saying, based on how this goes, if we are a no-go, then we have another shot at orbiting the moon and doing a powered descent initiation. But if we're go, Blue Ghost will take the wheel and perform that autonomous descent operation Bridget just went over with us. Now let's
GNC
go.
verifies step 46.3.
We're going to go
Falcon
ahead.
on Ops, 5 minutes to power the descent ignition.
Perfect. We heard that 5-minute call
All
out.
consoles 1 minute away from PDI go, no-go poll. Step 47.2.
Let's tune into the Mission Operations Center and listen for that poll.
So what y'all are seeing on the screen here are those positions in the Mission Operations Center, and we'll see those light up as they give their go or no-go commands.
And on our screen right now, we are seeing our flight director, right?
That's right. So that's Charles right there. He's our flight director for this mission.
Falcon on Ops. SLU is complete. GNC verifies step 46.4.
Right, everything continues to remain nominal as we stand by for that go, no-go poll.
Falcon on Ops, VNS is reporting position covariance below 50 meters.
And that VNS is our vision navigation system.
Thermal state is 11. We will be starting PDI at 97% state of charge.
All consoles, flight on ops, PDI cannot be aborted if the lander has transitioned to descent critical. Also at this point, we're going to proceed with our power descent initiation go, no-go poll, starting with payload.
Go.
COM.
Go.
Ground software.
Go.
Flight software.
Flight software is go.
AVI.
AVI is go.
VNS.
VNS is go.
GNC.
Go.
FIDO.
Go.
Prop.
Go.
TCS.
Go.
Systems.
Go.
C.
Go.
FC.
Go.
All consoles, Blue Ghost lander is a go for power descent initiation.
And y'all heard it
Falcon
from
on
Charles.
Ops, 3 minutes remaining until power descent initiation.
We are go for the powered descent initiation. In the next 15 minutes, we're going to tune into our Mission Operations Center as the team monitors the vehicle and prepares for that final descent.
Now, there are some of those visuals that you were describing earlier in the show, Bridget. So we can see our countdown clock where we're about 14 minutes, just almost under 14 minutes from landing. And we have that visualization of Blue Ghost as it's continuing its horizontal trajectory, getting ready to get into that vertical mode.
Exactly. And so, like we said before, that's real telemetry that's driving that simulation y'all are seeing on your screen here. That yellow vector you see off to the left, that's pointing in the direction of the sun. And that blue vector there is the direction of the Earth.
And we see those foot pads as well as all of the engines in this image. So really exciting to see our MOC, our Mission Operations Center, as well as that data-driven telemetry. All right, if you are
All
just
count on ops. 2 minutes remaining to power descent ignition.
with that 2-minute call out, if you are just joining us, this is the NASA Firefly joint broadcast for Blue Ghost Mission 1 as part of the agency's Commercial Lunar Payload Services initiative. We are standing by as PDI process and procedures do continue. Just as a reminder to those of you who are tuning in, the graphic visualization that we do see is has about a 15-second delay, and we did cover that at the top of our broadcast. So just as a reminder, there is that 15-second delay. So we may actually hear that call for landing before the data does get there, but we would like to point that out and keep that in mind as we continue to follow along.
That last call out you heard was propellant settling, so we actually use these ACS thrusters that will
60 seconds to PDI.
that'll help settle that propellant, so the propellant's where it's needed to in that fluid system for ignition.
So exciting.
Fun fact, we actually use those ACS thrusters on our Alpha launch vehicle as well.
You know all about propulsion and engines. It's fascinating. I'm learning so much today.
30 seconds to PDI.
And there you see a couple folks on console. So that is Raj and Will Adams. So they are supporting on TCS and prop. So our propulsion and thermal control systems.
10 seconds to PDI.
Let's stand by and tune in to mission
7,
ops.
6, 5, 4, 3, 2, 1.
So the lander is performing that 9-minute powered descent initiation using all of its engines to reduce. And you can see that on the simulation right there with
Main
the
engine
engines
on.
going. Main engine is on. We see that
Descent critical.
call
All
outs going
consoles,
on.
flight on ops, and abort is no longer possible.
Right, teams have been practicing for this moment, and we see that taking place right now. And this is where the lander is positioning itself closer and
Ignition
closer.
temperatures nominal.
Nominal callouts.
Guidance mode, D'Souza, 48.1 confirm.
And we heard that D'Souza guidance.
Attitude and rate errors look like they converge back to nominal after the transition.
Current draw is nominal. Tank pressures are stable, prop is nominal.
And remember, this burn lasts
VNS is stable, nominal.
about 9 minutes.
Navigation filter is well behaved.
We love when things are well behaved.
Exactly.
We just heard the call. That comm is stable as well.
Comms link is stable.
It's during this burn where we were going
All count on ops. 9 minutes remaining to pitch over. 455 kilometers south of the target, 16 kilometers above it.
We're reducing our velocity down to 40 meters per second in this burn. And so on that gauge, what you'll be looking for is about 144 kilometers per hour.
And just as folks are tuning in right now, our PDI is actually that braking burn. So we're continuing to slow our speed down and bring the vehicle from a horizontal configuration or horizontal orbit into a we're pitching over the lander into a vertical configuration.
Exactly. All of our RCS engines are firing at a mid to high throttle here in the anti-velocity direction to slow us down. We're shedding all of that horizontal velocity like you're saying.
Eight minutes remaining to pitch over. 370 kilometers south of the target, 17 kilometers up.
So 1 minute completed of that 9-minute braking burn.
Attitude and rate errors remain nominal.
Alcon and ops, VNS is passing over a shadow.
And so what you guys see on the screen here is that graph taking us through all of the different phases into landing. We are in that power descent initiation.
VNS is past the shadow and returning to lower covariance.
Main engine temperatures continue to rise nominally.
How are you feeling?
Excited, nervous, anxious. Lots of feelings.
7
going on
minutes
right
to
now.
pitch over. 290 kilometers south, 16 kilometers up.
GNC flight on ops, verify 48.2 when ready.
Wilco.
So we are seeing our various folks in the Mission Operations Center that are continuing to follow along during this braking burn called Power Descent Initiation, or PDI. All operations continue.
Engines trimming out, target achievable, 48.2 confirm.
Batteries at 92%.
In the front left of the room there, where the camera's pointing, you're going to see that's 100% of those teammates with us from ASI and Space NG. So you're seeing folks from ASI, GNC1, GNC2, FIDO. You got Space NG with Vision Navigation Systems.
6 minutes remaining until pitch over. 222 kilometers south, 15 kilometers up.
All right, we can hear that number.
VNS is crossing over the final ridge as we enter the Marcrisium.
We're getting closer and closer to our landing site, Mare Crisium, on the northeast part of the moon, on the side that faces us here on Earth. Now there is a NASA console position as well.
Temperature inbound.
That's right. They're on the opposite side of the room, probably in the corner the camera can't see right here.
And that's to conduct all of the 10 payload surface operations over the course of the next 14 Earth days or 1 lunar day.
That's right.
And I think that's Farah,
Navigation
right? That is
filter looks
Farah.
nominal, and Star Tracker is still in lock.
So she's sitting in our payload seat. So she is, she's been phenomenal on this
Power
mission.
is nominal.
And she's been with all of the payloads since the beginning.
I remember interviewing her for our podcast, and she was phenomenal. She knows these payloads like the back of her hand.
5 minutes remaining until pitch over. 140 kilometers south, 13 kilometers up.
So Farah's there tracking the health of the payloads and making sure everything is performing as expected.
Absolutely. Yep. And we actually have 3 payloads on site for landing. We have EDS, Lister, LPV. The rest will be remote.
So 3 out of the 10 payload teams are currently near the Mission Operations Center on site, and the remainders have their own control centers in other locations.
And so this is a primary operations
VNS is
center.
seeing drops to validate.
They
and back to
actually,
global.
there's some backup rooms upstairs too for secondary, tertiary, and extra data review. Eyes up there.
So you talked about
4 minutes remaining to pitch over. 110 kilometers south, 10 kilometers up.
And on the screen right now, you see Joseph Marlin and Will Coogan. These are our CEs, our chief engineers. A fun fact, Will Coogan actually used to be a carpenter before he went back to school for his
sees
PhD.
that we're in validate, so we're not global positioning.
I think having all these varying backgrounds really helps you in your current work. So it's really impressive to see this team coming together. And not only are we seeing the teams in the room, but there are folks that are in back rooms, as you mentioned, that are also supporting this mission
Batteries
today.
at 90%.
Exactly.
So we see that speed has come down.
VNS now sees we're back in global generating solutions again.
That's 7 kilometers from the surface. That braking burn continues.
Falcon and ops. 3 minutes remaining until pitch over. 67 kilometers south, 7 kilometers up.
Getting closer and closer to that lunar
System temperature
surface.
still nominal.
Attitude and body rate errors still nominal.
Like we were saying before, the Fireflies, we don't sit still in one position, one role too long, and so we do for sure have a lot of cross-functional teams here.
And there we have our flight director back, tracking this mission. I'm appreciating the call outs. They're easing my nerves a little bit right now too. So that spacecraft, as you can see on the graph right now, is getting ready to continue that braking burn and that pitch over to put it in that
VNS
vertical.
is reporting position covariance below 25 meters.
Two minutes remaining to pitch over. 35 kilometers south, 4 kilometers up.
We are standing by for continuation of that powered descent initiation or braking burn. This is where all engines are firing to pitch
GNC
over.
flight on ops, verify 48.3 when ready.
That was Charles. Do you know what seat's missing, what subsystem?
What are we missing?
Structures.
Flight laser rangefinder has measurements.
VNS reports position covariance at 10 meters.
1 minute remaining until pitch over. 13 kilometers south, 2 kilometers up.
We'll actually add in that mechanisms and structures seat
Power
in
is nominal.
right after landing. Alex Kaplan is our engineer there, and he's designed all 3 mechanisms on board the lander that he helped also build and test. Those subsystems become much more prominent after landing, so we'll see him come in later.
So we do see that graphic come up we talked about a little later with the lander foot pads, so our contact legs will turn.
VNS position covariance below 5 meters.
30 seconds remaining to pitch over. 4 kilometers south, 900 meters up.
So those will turn blue once we've confirmed some level of contact. And we'll continue to track as we get closer and closer to the lunar surface over the course of the completion of this PDI. You can see the graphic on the screen demonstrating that Blue Ghost is getting into that vertical configuration and doing that pitch over as expected.
Man engine off. Terminal guidance. 500 meters up.
Battery's at 87%.
All right, from here on out, it is just going to be those Spectra
400
engines.
meters.
Now, just as a reminder, those Spectra engines that we see firing right now on our
GNC
screen,
and VNS flight on ops, verify 49.2 when ready.
they are doing those pulses.
VNS is in relative.
260 meters up.
First redirect occurred, 98 meters from original target.
1 minute remaining in flight.
The vehicle is converged on its commanded descent profile.
All right, so we are in that autonomous phase that you had described to us. She is ready and has been preparing for this.
You're going to hear a lot of call-outs here about vision navigation solutions, laser
Seconds remaining in
rangefinder,
terminal. 100 meters up.
And let's
health
just
systems.
Navigation filter is still healthy.
Second hazard avoidance occurred, 5 meters from previous target.
50 meters up. 30 seconds remaining in flight.
Payload verify 49.4.
Copy. Verified.
11 meters up. Vehicle and shutdown.
3 contact sensors tripped.
Engine shutdown confirmed. Power is nominal, vehicle is charging.
IMU reports lunar gravity and it is stable.
Alcon, Chief Engineer on Ops. Y'all select the landing. We're on the moon.
Firefly Aerospace just became the first commercial company in history to complete a fully successful moon landing. Congratulations to the entire team. This is such an incredible feat for Firefly, NASA, our nation, and the world as we pave the way for a lasting lunar presence.
Congratulations, Bridget. And to our Firefly and NASA teams, what a nail-biting moment in history. The joint teams are now celebrating or enjoying this much-deserved celebration at our landing event here in North Austin, Texas. This marks the beginning of the next phase of the mission, surface operations. How are you feeling, Bridget?
Honestly, overwhelmed. I am so proud of our team. Firefly has a way of constantly exceeding expectations. This is a perfect example of that. Over the last 4 years, so many dedicated Fireflies across different teams and disciplines came together to make this happen. Now we have a permanent presence on the moon with every employee's name engraved on a Blue Ghost plaque. So now when we look up at the moon, we can tell our kids and future generations that their family name is up there. Thanks to this team and everything they have achieved. But it's not over. We will be operating the payloads and gathering even more data that will make an even larger impact on the future of space exploration.
Congratulations.
Thank you.
And now this lunar lander is gearing up to conduct those surface operations and downlink that anticipated image from the lunar surface. So while we stand by for that, we have Tony back with some guests from NASA's Science Mission Directorate. Tony.
Here, we've got you right here. Welcome. Thank you, Nilifer and Bridget. Now joining us is Associate Administrator for the Science Mission Directorate, Nikki Fox, and then the Deputy Associate Administrator for Exploration with NASA Science Mission Director, Joel Kearns. Nikki, Joel, I mean, what a momentous occasion. How are you guys feeling? We're on the moon!
So my question is, what do you think of that Firefly team?
It is such an exciting time. I mean, what a huge congratulations to everyone. Now, Nikki, can you tell us a little bit more about why this landing location was chosen and why, Blue Ghost is on the near side compared to when some other landing sites are chosen for other of our Eclipse flights?
Yeah, absolutely. We choose, I'm sorry, I'm just so excited right now, but we choose our landing sites very carefully. Our Eclipse landers will go to the South Pole, to the near side, to the far side. This one in this really perfect location. We want to study the geological features on the moon. We want to study the interaction with the solar wind. We want to just learn more about the regolith. We want to be able to prepare for our future astronauts to go and keep them safe. And so we chose the science instruments perfectly to go to this incredible place on the moon.
That we did. And Joel, this is the most NASA science that we have sent on Eclipse flight thus far. Can you tell us a little bit more then? What is the primary goal, or what are we hoping to find then with all of this?
So we're landing in a place that's of great scientific interest, but it was also a very achievable place to land. And there are studies that range from studies of the sun that we'll conduct from the surface of the moon, studies of the abrasive dust of the regolith. We're going to drill into the surface. We're going to pick up regolith. It was going to answer so many questions over this one lunar day long mission. It's going to be really one for the history books.
That's right. And speaking then about all those questions that we're going to answer, Nikki, tell us, what then of the science and data that we learn on the moon, how can that help us back here on Earth?
So there are so many ways that, everything we do in NASA science is so interconnected. We study everything from the center of the sun to the edge of the universe. Right now, focusing on the moon, learning more about particularly things like, how that regolith, how it sort of interacts when we land, what the plume looks like, how sticky it is, if we can clean it off those surfaces, just telling us all about that. For us here on Earth, all this technology that we're sending up to the moon continually all has real-world applications as well. And so everything that we do, coming back and serving humanity and inspiring the world with NASA science.
That's right, we sure are. That's really fascinating. Talking more about, some of the scientific instruments that we're sending. As we know, Joel, some of those science instruments have flown on prior CLPS flights, and they're also scheduled to fly on future ones. Why is that? Why do we choose some of the same instruments for certain flights and different ones for others?
Well, we've only really been to a few places on the surface of the moon during Apollo or even with our robotic surveyor craft from the 1960s. There were a bunch of measurements we really want to take to characterize overall around the moon. Sure, especially the South Pole where our astronauts will go initially, but there are particular scientific questions where you have to take the same measurement on the near side or the far side in a mare, one of these frozen lava pools, as opposed to the Highlands Mountains, to really understand the moon, and based on that, to better understand Earth.
I can't wait for that. And, Nikki, talk to us then about some of the lessons learned then that we have, learned from now our other CLPS flights that were applied for this one or, for the future ones.
Yeah, I think one of the amazing things about our CLPS providers is they are all there for one another. Even today, Jason was sharing stories about what some of the other teams have been sending. Good luck to Firefly today. It is just an amazing community. And that is what we wanted to do with the CLPS program, was really get this sustainable commercial lunar economy and have it led by American companies. And that's so important to us. As Joel said earlier, we're not doing this as NASA. We're doing this in partnership with these American companies. And so, just seeing the community that we're building is just so, so amazing. And so just congratulations to everybody.
Yeah, very well put. To both of you, how are you guys feeling right now that we're on the moon?
I don't know, it's all in a day's work, isn't it? Really, it's a Sunday. No, honestly, it is so, so, so amazing. We were standing outside watching it, and Joel was getting instant, feedback from all those amazing people in the mock. And it's just incredible it was just, I don't know, seeing it come down and then you're suddenly like, oh my God, it's 5 kilometers above the surface. And so it's just an amazing, amazing achievement. I am so proud of everyone in this room because you all had a part in putting this lander on the moon. Whether you're a Firefly or whether you're a family member of a Firefly or whether you're a member of the amazing NASA science team, congratulations.
And remember, they made it look easy. It's not easy.
Thank you, Nikki, Joel, so much for joining us. Now we'll send it back over to our hostess, to Nilofer and Bridget.
Welcome back. For those just joining us, Firefly successfully touched down on the moon in an upright, stable condition, becoming the first commercial company to complete a fully successful moon landing. We expect to have the first image within the next 10 minutes, depending on the signal strength of our S-band antenna. The timing will vary based on the position of our lander and the ground stations on Earth. If the S-band data rate is limited, we'll likely need to switch over to that X-band antenna, which needs to be deployed and calibrated. At that point, we'll plan to share the first image during our press conference in a few hours.
And I don't know about you, but we're on the edge of our seat waiting for these first pictures. How are you, or how does it feel knowing that Firefly is leaving their mark on the moon?
I don't think there's another feeling that even remotely compares to this right now.
I'm sure you've been... So, you know what? I have to ask, because we talked all about the engines. We saw that great visual data telemetry. I know you have something else to show us. Do you have anything else here?
I always have goodies. I always have props.
You did work on our engines.
We love hardware here. Let's get take a second here
We're
to
just
get
doing
out.
a quick safety briefing on, or a safety practice on something that Bridget has for us to see today. Oh, this is cool.
It is cool. Oh, let's move this out of the way here. All right, so I love talking about Spectre. This is that 200 Newton Hypergol engine. You will notice I am wearing gloves.
Right.
The hypergol propellant is actually a toxic propellant, and while this has been completely decontaminated, we still want to take safety precautions just in case. But yeah, you can tell that this, so there are, if you want to actually show on that lander, but there are 8 of these engines on the lander. So we have pairs on each side.
Right there. All right.
Exactly.
Okay, so we see our 8, and those are the Spectre engines that we see right here. Got it.
And so, and then these are, it's a biprop engine, so we have 2 different propellants here.
Okay.
And because it's hypergol, we don't need a third ignition source. They just ignite on contact with each other, which is pretty cool. And these are our Kraken main valves. We love to have fun names here at Firefly. And then it'll go through the injector here, combust in that thrust chamber, and then expand out through the nozzle. It's pretty impressive. So this is what the team designed, developed, tested, and built in about a 2-year time frame.
And these 8 Spectre engines, those were the ones that were firing in those quick pulses like you described, like a bird flapping its wings or at the blink of an eye.
Exactly. So they just continue to iterate and pulse just like that.
You've taught me a thing or two on these engines. I really appreciate that, Bridget. So how are you going to be celebrating this moment with your family, with your friends, with your fellow Fireflies?
I'm going to go home and give my kids a great big hug, first off, and then maybe sleep a little bit. All right, and so while we wait for that photo to come in, we're going to go back and check into the stage with Tony.
Hey, thank you, Bridget. We are now here with Jason Kim, the Chief Executive Officer for Firefly. Jason, congrats on landing on the moon.
Congrats to all of our Fireflies.
How is it, how are you and the Firefly teams feeling right now?
They're just fired up right now in the mission control room. I mean, they were just pent up, holding it all in because they were calm and collective and cool the whole time. Every single thing was clockwork, even when we landed. And then after we saw everything was stable and upright, they were fired up. They were fired up. We got some moon dust on our boots.
That's awesome. And now you can use the EDS shield, EDS payload to take that off.
Yes, I love that EDS payload. I love all the payloads.
Absolutely, we love all 10 NASA payloads, that's right. Jason, this is Firefly's first moon landing. What message would you like to give to the team that have worked so hard on this mission?
Well, I'm just in awe of all of them. I've been that way since I, witnessed the company, during their launches, and then finally with this whole campaign. I'm just in awe of all of our Fireflies and just all the hard work that they put into this, all the extra sacrifices they did from their family and friends. So thank you to all the family and friends. All that design work, all the testing, all that simulation, it finally paid off. And we're just so glad and happy for our team.
Absolutely, and now you're on the moon. I mean, Blue Ghost is finally on the moon. What do you think, or what do you hope that this mission means, or this message sends to all the aspiring and future engineers and scientists that are looking to one day enter the aerospace industry?
Well, if you look at everybody in that mission control room and everybody at our company, you don't have to always be a rocket scientist, although we have some great ones at the company. We have people from all walks of life, and in that control room, people that started off with music careers or seamstress or welders. They're all from all kinds of careers, and they just landed on the moon. So, we hope this inspires the next generation of kids and STEM, K through 12, because, have them dream big. You never know where you're going to land. We just landed on the moon. So we hope that the Fireflies today inspired a whole generation.
That's right. There's space for everyone in space.
That's right. Especially in Texas.
It was discussed earlier, Firefly not only develops lunar landers, but you guys also build and launch rockets. Can you tell us a little bit more about what else is in store for the Firefly team?
Well, you know, right after this, we're going to get ready for our first launch of the year. We're going to launch our 1-ton rocket called Alpha. It's America's rocket, and we're going to launch Lockheed Martin's LM-400. It's their mid-class satellite. It's a beast, and we're just honored to launch that satellite. And we're going to launch multiple times this year. Things like Victus Haze for True Anomaly, and there's other, you know, Space Force missions that we have. So we're going to continue to launch at cadence, and then we're delivering our medium launch vehicle first stage by the end of the year. We just finished our first stage LOX tanks, so we're incredibly proud of that. And then, you know, we're working on Blue Ghost 2, Blue Ghost 3 as well, so we're not done. We're not finished with these moon missions. And, you know, I think there's this Electra spacecraft that we don't hear too much about. That's a space maneuver vehicle, and we're going to launch the inaugural one this year for a responsive NRO mission.
You got a lot of things coming up. I mean, do you have a favorite?
My favorite is always the next one. The next launch, the next lunar lander, the next one.
Very well put. You know, I know we're all very much looking forward to that. Jason, thank you so much. I mean, everyone here is so excited. Can we get another cheer from the crowd? Awesome. All righty, well, we'll go ahead and send it back to our hostess, to Nilofer and Bridget.
Thank you, Tony, and thank you, Jason. Congratulations once again. If you are just joining us moments ago, Firefly became the second American commercial company to touch down on the moon with its Blue Ghost lunar lander. Now, we're standing by right now for that first moon image, which we expect in the next 15 minutes or so. So while we wait, Bridget, do you mind giving us a little bit of a preview on what's next for this mission?
Yeah, sure. So this is going to be the beginning of our surface operations. Within the next 2 hours, Blue Ghost will perform surface commissioning in order to activate each subsystem and perform health checks. We'll also deploy and calibrate that X-band antenna that we spoke about earlier. That's going to increase our bandwidth and begin downlinking HD imagery and video. And then following surface commissioning, we're going to begin those 14 days of the payload operations.
Great. So that includes deploying that surface access arm with the lunar planet vac sample, that little vacuum to collect some samples.
Right up there, you can see on the screen. And then Blue Ghost is also going to deploy 4 tethered lunar magnetotelluric sounder electrodes, or LMS, on the lunar surface, in addition to a mast on Blue Ghost's top deck, which stands 2 meters above the lander to help study the deep interior of the moon. We'll also begin subsurface drilling operations with the Lister payload that remains attached to Blue Ghost.
So that will be really great. And after the first image, there's a lot more to come from over the 14 days of surface operations, literally. There's that solar eclipse that the team expects to capture on March 14th, where the Earth blocks the sun from the moon's surface. And then we also have a few days later to capture that lunar sunset we discussed early on in the broadcast, but that is expected on March 16th, where it will verify that dust levitation phenomenon that was seen at the last Apollo, when the last Apollo astronauts were on the moon during Apollo 17.
Exactly.
And so finally, Blue Ghost is expected to operate for some hours into the lunar night as well. So it means that there's still so much to look forward to during this mission. I'm really excited.
Me too. And so while we continue to stand by for that first moon image, we're going to go ahead and check back in with Ray, who was just in the Mission Operations Center with the Firefly team during that impressive landing.
Hey, thank you, Bridget. Joining us once again is Ray Allensworth, Firefly Spacecraft Program Director. Ray, I mean, how you feeling? What an awesome time.
That's amazing! My heart's beating so fast.
I know, I can see that. It's so exciting. Yeah. You know, you were just in Firefly's Mission Operations Center. Can you tell us how everyone was feeling in that moment, what it was like?
It was so quiet for just like, I mean, it was like a 9-minute burn, 12 minutes, like getting, through PDI, pitch over, and then you just hear these 4 call outs. And I think I'll just forever hear like our chief engineer Will's like voice, like we successfully landed on the moon, and then just everybody kind of lost their minds. I'm sure y'all did too. Yeah.
We sure did. It was great. Now Blue Ghost is on the moon.
Yeah.
What's the team doing now?
So they're all business again. So I had to leave because I couldn't keep it together. So they are immediately going into health and safety, and then it's really just immediate into payload ops. So we landed at the beginning of the lunar day, and we want to maximize as much of that time as possible for all the payloads. So they will immediately dive into that, and really these first 3 days after landing are going to be just jam-packed. Just try to get every single payload op going that we possibly can.
Can you talk to us a little bit more about those surface operations and now kind of some of the most exciting moments that we can look forward to while Blue Ghost is on the moon?
Yeah, so I like to say that when we land on the moon, I think the lander kind of comes to life. The Lister drill will go down, the surface access arm will deploy, we'll have probes coming off the side of the lander, so a lot of different payload ops, but there's also a couple other phenomena that we'll see on the surface. So we will witness an eclipse while we're on the surface, and then at sunset, we expect to see this kind of phenomena where the dust levitates off the surface. So that we'll try to, we will photograph and video all of that.
That is so cool. When it was being discussed earlier, that lunar sunset, I think we were all like, wait, what are we going to be looking at? Exactly. Yeah. No, I love that. This, as was mentioned, isn't going to be the only lunar mission for Firefly. Can you tell us a little bit more about the upcoming ones, what we can expect, how those will look?
Yeah, absolutely. So Blue Ghost Mission 2 is well underway. We're moving into the integration phase of that mission. That mission is really special because it's not just a lander, but it's also our Electra vehicle that's going with it. So that'll help get it to lunar orbit. And then once we deploy Blue Ghost in one of our NASA payloads, that will actually act as a comms relay. So that is, far past CDR in integration, getting ready to go. And then we just did our kickoff for Mission 3. So we're going to be pretty busy for the next couple years.
Very busy. I mean, and you just mentioned for the next lunar mission, you have to use, it's not just going to be the lander that you're sending, you're also using the orbiting spacecraft, the Electra vehicle. Tell us how that works, why it's needed, for Blue Ghost Mission 2.
Yeah, so Blue Ghost Mission 2, we have a lot more payload mass, but also we're deploying a fairly large payload lunar pathfinder into orbit. The transfer stage will get that whole stack to lunar orbit once we deploy from the launch vehicle, and then it deploys LP, and then again, it's staying as a comms relay, so we'll be on the far side. So we're really designing that vehicle to be able to operate for 5 years. So it's a pretty robust vehicle, and it shares a lot of heritage from the lander.
That's really cool. I cannot wait for that one to get underway. And as you mentioned, the second mission, that's going to go to the far side. Are there any challenges or any differences, I guess, with landing, right now on the near side compared to now for the next one that's going to be a different location?
I think we know less about the far side. So, we had a relatively good amount of data for our specific payload site for Mission 1. We're landing equatorial far side on Mission 2. A little less familiar with that area, but really, it's really well suited for the payloads because they want it to be totally radio silent. So it's dark in that regard. We'll learn more about it as we go through integration and the mission ops phase for that mission.
That is super exciting. I can't wait to learn about all the different things that you guys uncover along the way. Now, Ray, for you personally, I guess what's next for you? What are you going to be doing for the rest of this mission, or are you now full steam ahead on Blue Ghost Mission 2?
I'm going to go to sleep and then just dive right into surface ops. I'll be in the mock a lot, and then maybe a PTO day or two, and then just Mission 2.
Well, you definitely deserve a day or two of PTO. Ray, congratulations once again. Thank you so much for joining us. Now, we'll send it back to our hostess, to Nilüfer and Bridget.
Thank you, Tony, and congratulations to both of you once again. In case you missed it just moments ago, Firefly successfully landed on the moon at 2:34 a.m. Central Time. The Blue Ghost lunar lander safely touched down in Mare Crisium, delivering those 10 NASA science and tech instruments. Now, we should just give a heads up that we do expect another image, or their first image rather, to come through in approximately the next 30 minutes. We are standing by for that, but let's talk a little bit more about what to expect and what took place over the course of the landing. So let's take a look at that incredible landing. Now that we're on the surface, we're, like I said,
Payload verify 49.4.
Copy. Verified.
11 meters up. Vehicle
Contact.
shutdown.
3 contact sensors tripped.
Engine shutdown confirmed.
Power's nominal vehicle is charging.
IMU reports lunar gravity and it is stable.
Alcon, Chief Engineer on Ops. Y'all select the landing. We're on the moon.
Firefly Aerospace just became the first commercial company in history to complete a fully successful moon landing. Congratulations to the entire team. This is such an incredible feat for Firefly, NASA, our nation, and the world as we pave the way for a lasting lunar presence.
congratulations, Bridget. And to our Firefly. So now we're on the surface and we're standing by, as I mentioned, for that first image, which should be ready in just some moments. But Blue Ghost is on the moon for the first time. And we know that image won't be the same quality that we've seen over the course of this mission or while it was in transit. And that's because she's just getting settled in her new home and getting all of the comms and things sorted out. Teams have been working towards this moment and will continue to stand by as we anticipate that image. We also want to check back in with Tony, who's with Chris Colbert. Tony?
Thank you, Nilofer. Joining me is Chris Colbert, manager for NASA's Commercial Lunar Payload Services Initiative. Chris, I mean, what a time to be alive.
Woo! We did it! Congratulations, Firefly. Awesome job.
That's right. Now, Chris, can you tell us why it's so important that NASA has the CLPS initiative and that we have multiple companies sending our NASA instruments to the moon?
So CLPS was designed to help us learn how to go to the moon. We haven't done it in 60 years, and we're doing it a different way, utilizing commercial companies to get us there. We're using multiple commercial companies because we want to be able to fly a lot of missions relatively quickly. So we're hoping to get lower cost missions at a faster pace, and we just have proof it works. We landed on the moon almost perfectly.
That's right. You know, and speaking of the moon, I guess, why the moon specifically? Like, why was that location chosen for CLPS as opposed to any other location in the universe?
Well, let's start with the first part is because the moon is close. It's relatively easy to get to. We can get to it in just a few days. But it's also a key part of the Moon to Mars strategy for the agency. The Artemis program and getting humans back to the moon and on to Mars. Starting here with the smaller landers and letting us learn about the moon is a big part of what CLPS is for.
You know, on that note, do you think then that CLPS could one day expand to cover other destinations like Mars?
Well, what I think we're seeing here is that commercial companies are very successful. So we want to take advantage of those capabilities and the growing industrial base in the United States and the American companies, what they bring to the table to allow us to broaden our exploration. It's a key part of the Artemis strategy is to take advantage of commercial companies. And as we just proved tonight, they can do it. They can do it really well.
That's right. You know, now that we have another commercial company on the moon, how does it feel to see this initiative underway and producing results?
It's astounding. This is amazing. I can't say enough good words about the Firefly team. They did just such amazing work all the way through, and that was kind of a picture-perfect landing. Everything worked beautifully all the way through this mission. They knew what they were doing. They solved every problem that came in front of them. This is just an amazing feeling. It demonstrates that what NASA started with 5 years ago can work, that we can utilize these commercial companies at a fraction of our normal cost, and we can get to the moon. We've got another landing coming up in just 5 more days, and 6 more planned over the next 3 years. So we've got a lot of things coming, and this works.
That's right. I mean, you just mentioned we have another moon landing coming up very shortly. Can you tell us a little bit more about those future CLPS flights, what we can look forward to and when?
Sure. So part of what we're doing here, Nikki Fox mentioned it earlier, we're helping learn more about the moon to prepare us for taking humans back. So we're flying an increasingly complex series of instruments to the moon and demonstrations of technology to help advance our capability prior to taking the humans there, to make it safer and more productive when they do get there. We'll see those missions scattered out fairly consistently over the next 3 to 4 years as our instruments are matured and put together, and we take advantage of what we learned from these early missions. You've heard a lot today about the instruments on this mission. We'll learn from those instruments and make adjustments to the instruments we fly in the future. And you'll see those spread out over the next 2 to 3 years so that by the time we take humans back, we know a lot about the moon.
That's cool. I'm very much looking forward to that. I mean, Chris, you know, thank you so much again for joining us here. Now, we'll send it back to our hostess, to Nilofer and Bridget.
Thank you both, and thank you, Chris, for guiding the entire CLPS team since day one. I know it's an accomplishment, and I know that I am not alone as I express gratitude for your guidance and support over the years. We are all so grateful for you. Now, we do have something exciting that we've all been waiting for. Do you want to tease the audience a little bit more, or what do you think?
Well, we have that lunar image ready.
Do we?
Let's go ahead and share that with the team here.
All right, you're seeing it here first.
Look at that view.
I'm feeling a little bit emotional, and I'm feeling over the moon. Now, when I look up at the moon from down here, I will always remember this exact moment and the fact that Blue Ghost Mission 1 is in the northeast region in Mare Crisium. What an incredible sight. Bridget, can you tell us what we're looking at right now?
Yeah, so this will be one of those cameras on the lunar lander. We're looking at that lunar surface, so you can see the various features of that regolith, the crater, some rocks, and that vision navigation system did such a phenomenal job finding what looks like a relatively flat surface for us to land on. And then obviously you can see some portion of our lander in that image as well.
Now, this is that low-quality image we anticipated, but Firefly expects to share more imagery and insights at the upcoming news briefing.
That's right. We'll get that X-band imagery, and then we'll actually also be able to get that video from landing.
Now, before we get ready to wrap, what else is next for Firefly, Bridget?
In the coming weeks, Firefly is scheduled to launch Lockheed Martin's LM-400 satellite on our next Alpha rocket. The Firefly team is also gearing up for our next mission to the moon in 2026, and that mission is part of another NASA CLPS task order. But this time we're going to utilize a 2-stage spacecraft configuration with Firefly's Blue Ghost lander with a stacked Elytra orbital vehicle to support operations in lunar orbit and on the far side of that moon. To learn more about the rest of Firefly's upcoming missions, you guys can always check out fireflyspace.com/missions. And I know NASA has a lot coming down the pipeline, too. What do y'all have in store for us?
We do. We are busy. So CLPS continues to be an example of how NASA is enabling commercial services at the moon to support long-term lunar exploration. We have more CLPS deliveries that are planned through 2028, and the next CLPS lunar landing is coming up. Intuitive Machines' IM-2 mission is just days away to landing on the moon on March 6th at Mons Mouton, which is near the moon's south pole, which you can follow on all of our NASA channels. On top of the next moon landing, we also have a launch. We're launching 2 new NASA science missions together in the coming days. NASA's newest space telescope, SphereX, and its rideshare Punch will lift off from Vandenberg Space Force Base in California. Now, then after that, we do have the launch of Crew 10 to the International Space Station, which is targeting no earlier than March 12th, as well as the return of Crew 9 shortly after. And beyond that, there's Artemis 2, the first crewed mission of the Orion spacecraft and Space Launch System rocket, which is scheduled for no later than April 2026. Bridget, it's been a privilege to sit next to you as we go through this historic moment, and we are looking forward to that all-important data that Blue Ghost will gather from the lunar surface. So thank you so much for joining us for this joint moon landing coverage of Firefly's Blue Ghost Mission 1, which delivered 10 NASA instruments to the northeast region of the near side of the moon.
And that's going to be a wrap for us tonight. We are incredibly proud of what this team has accomplished today. We want to thank you all for joining us. Be sure to tune into the joint Firefly and NASA press conference that's set to begin at 4:30 a.m. Central or 5:30 a.m. Eastern on NASA Plus and Firefly YouTube. We do plan to share our HD imagery we talked about and that descent video during that time. And we'll also provide more in-depth updates on the mission ahead.